Hi everyone. In this video, I want to show you a little bit of where some of the formulas that we're going to use come from. Well, one of them anyways. So we're moving into two sections, 3.2 and 3.3 are going to be sections where we learn specific formulas and we apply them. So there are formulas that tell you how to split up the cosine or sine or tangent of the sum or difference of two angles, how to rewrite the cosine or sine or tangent or any of them of 2 times a known angle. So they just allow us a little bit more flexibility in dealing with mess involved with trig functions. So here, I'll give you a little peek beforehand. Okay, so this is the list of sum and difference formulas. So there's really 4. I've kind of lumped them together though. If you have cosine of u plus v, then you get this formula and you use the minus. If you have cosine of u minus v, then you have this formula with the plus. And the same thing for sine, except sine doesn't switch on you. When you have a plus here, you also have a plus here. When you have a minus here, you also have a minus here. So these are the sum and difference formulas. If you know something about what's happening at the end of arc length u and v individually, this formula tells you how to find out what's happening at the end of u plus v or u minus v. Okay, so I want to work on the u minus v. And this is admittedly sort of just to show you where something cool comes from. So if you're not a fan of seeing that, you can skip in a little bit. But I do want to show this. So let's say, here, let me pick out some colors. Let's say we have arc length U. And this could look like anything, but I'm just going to draw it on the top of the circle for convenience. Okay, so let's say that's arc length U. Lands over here at some point. And then we have arc length V right here. And it lands also somewhere in quadrant 2. So if we look at this, we can say, all right, well, there's this little segment right here, this u minus v. So that's how long that is. That's u minus v. And we can even shift that u minus v around and put it over here in standard position. So I'm just going to sort of estimate, okay, this is about this long. So let's say it ends up being, this is supposed to be the exact same length. So that's u minus v in standard position. Okay, so I want to actually look at some of the individual points going on here, and then I'll tell you where we're going from there. So at the end of arc length V, we have a point, and its coordinates are cosine V, sine V. And at the end of arc length U, we have a point whose coordinates are cosine u, sine u. And again, this is just the definition of sine and cosine. This is what they tell us. On the unit circle, they give us our x values and y values. And then there's a point at the end of u minus v, and that point is cosine u minus v, sine u minus v minus v. There we go. Okay. So here's what we want to do. We want to get the distance formula involved, which you've probably seen at some point. Don't panic if not. It's really just a Pythagorean theorem. If we're sitting in the xy plane and we have coordinates of points, we can draw a triangle that connects those 2 points. So it has a vertical side, a horizontal side, and the hypotenuse connects the 2 points. And we can use the Pythagorean theorem to figure out the hypotenuse of that triangle, which is the distance between the points. So if you don't remember, this is what the distance formula looks like. Okay, so here is what I want us to see. Oh, I need to label one more point. I'm missing one. It's an easy one, though. Okay, that one as well. What I would hope we see is that since that arc length, u minus v, is the same whether it's over here between our 2 points or over here between our 2 points, we should be able to write out a giant mass. We'll see if I can make it fit on this paper, and get a true statement using the distance formula. So basically, we want to say, let me name some points. If this is point A, and this is point B, and this is point C, and this is point D. The distance from A to B should equal the distance from C to D. So that's what's going to build all of this. We're going to say the distance from A to B equals the distance from C to D. Okay, so using the distance formula, it says take the difference between your x coordinates, square it, take the difference between your y coordinates, square it, add them up, and square root. So let's start with A to B. The difference between our x coordinates is going to be cosine, I don't know if it matters which order, cosine V minus cosine U, and you square it. And then the difference between our y coordinates will be sine V minus sine U, and you square it. And then you square root that whole thing. Okay, so that's the distance from A to B. Maybe you can begin to see how I might run out of room for a little bit. Oh, and there's a plus in the middle. The distance from C to D, I'm going to preemptively say, let's just run this down and give ourselves a little more room. Okay, so we want the difference between our x coordinates, which is going to be cosine U minus V minus 1. We want to square it. And then we want to add on the difference between our y coordinates, which is actually really nice. It's sine U minus V minus 0 squared. And then we want to square root. Okay, so those two distances should be equal. And really all it is from here is playing around with some algebra to try and get a little bit simpler statement out of this. So the very first thing I'm going to do is I'm going to say, okay, well, if those two things are equal, I should be able to square both sides of this equation, get rid of the square roots. So now I have cosine V minus cosine U squared plus sine V minus sine U squared is equal to cosine U minus V minus 1 squared plus, and I'm just going to rewrite this, sine squared U minus V. Since it's only a sign in there, we can use the notation for powers on trig functions. Okay, so this is the statement that I'm working on. I want to go further. This is probably going to make it too big to fit on one line again. I'm going to start multiplying some things out. So here, you want to think about this as cosine U minus cosine V times itself. And when you multiply that out, you're going to get cosine squared U minus cosine U cosine V minus another cosine U cosine V. So minus 2 cosine U cosine V. And then you're going to get a plus cosine squared V. Okay, so that's only this first chunk. We need to do the same thing with sines. So we're going to get a sine squared V minus 2 sine V no, not sine V, sine U, and then plus sine squared U. Okay, so all of this is going to equal, I'm going to do the same thing on this side. It's a little nicer, but I'm going to say if I take a cosine U minus V minus 1 and multiply it by another cosine U minus V minus 1, I'm going to get a cosine squared U minus V minus 2 cosine U minus V plus 1. Okay, so if you can keep track, I have this whole line is equal to this stuff down here. So now some nice things are finally going to start happening. I think we've done the terrible part here, the really messy part. Okay, so notice I have a cosine squared U plus, where is it? Plus a sine squared U. According to the Pythagorean theorem, that's going to turn into a 1. Okay, what else is nice here? I have a cosine squared V plus a sine squared V, which is also going to turn into 1. Notice it really is important. I couldn't say cosine squared U plus sine squared V equals 1. They have to be the same angle, but I have two really nice pairs. And then anything else good? It doesn't look like it. I have a negative 2 cosine U cosine V minus 2 sine u sine v. And then on the other side, what do I have? Oh, I lost something on the other side. That's why I'm not seeing it. I squared this cosine u minus v minus 1. That's this. But I lost track of this sine squared u minus v. Okay, so now that I put it back, I have cosine squared u minus v plus sine squared u minus v, which is 1. And then I have a negative 2 cosine u minus v left over and a plus 1 left over. Okay, so there's all of it. Oh, there's all of it except I was off the page. Oh, sorry guys. Okay, so there's that one. So I have a 2 minus 2 cosine u cosine v minus 2 sine u sine v equals 2 minus 2 cosine u minus v. So just combining all the ones. Okay, so notice for starters that I can subtract 2 from both sides, and that's gone. And I can also, and this could happen in either order, divide everything. In fact, I think I'm going to divide by negative 2. And I get that cosine u cosine v plus sine u sine v is the same as cosine of u minus v. Okay, so if you stuck with me through all of that mess, I'm not going to do this for all of them, but I really just want you to see that these formulas don't just come out of thin air. They come from some geometry, and in this case, it is just that distance formula that can do it for us. So if you look, it's in the opposite order, but that's that first one. Cosine of u minus v is equal to cosine u cosine v plus sine u sine v. So that's our first formula, and using other geometry tricks, you should be able to figure out the other ones as well. Okay, so again, this is your, we'll just switch to this. This is your list of formulas for this section. There are 4 of them. You don't have to memorize them. I will provide them on exams. If you look in WAMAP, you should be able to find that, I think I called it Identities Cheat Sheet, and it has a list of the formulas I'm going to give you, so you can look at that and use that as you're studying. So these you do not have to memorize. You need the fundamental identities. These, I just want you to know they're out there and have kind of the general idea of what they do. So I'm just going to do one quick example, so there's at least something concrete in this video. So one way we could use this isn't super convincing when there's so much technology, but we can use it to break up the unit circle into even more special values. So for example, if I wanted to know what 19 pi over 12 is exactly, not a decimal approximation from my calculator, but exactly. If I could get clever about splitting that up into pi over 3s and pi over 4s, the sum and difference formula would be able to help me figure that out. So I've already done it for you just so you could see this. Pi over 3 plus 5 pi over 4. So if we got a common denominator, it would be 4 pi over 12 plus 15 pi over 12, which is 19 pi over 12. Okay, so using that, I can say if I want to find the value of sine of 19 pi over 12, that's going to equal sine of pi over 3 plus 5 pi over 4. And I have a formula right up here that says if you want to find the sine of the sum of 2 angles, you can break it up and say that's the same as finding the sine of the first angle multiplied by the cosine of the second angle. And then for sine, it stays plus. On your cheat sheet, I have them all broken out separately. So if you're not loving this plus minus business, that is split up for you. And then we would need a cosine of the first angle times a sine of the second angle. 5 pi over 4, squash. Okay. And these are all known things. So if I'm thinking, okay, pi over 3, that has coordinates 1/2 root 3 over 2, and 5 pi over 4 is -1 over root 2, -1 over root 2. So I can just kind of fill in the blanks over here. Sine of pi over 3 is root 3 over 2. Cosine of 5 pi over 4 is negative 1 over root 2. Cosine of pi over 3 is 1/2. Sine of 5 pi over 4 is negative 1 over root 2. And I can do a little bit better. So I have a negative root 3 over 4. And actually it ends up being minus 1 over, oh, what am I saying? Negative root 3 over 2 root 2. And then it's a negative 1 over 2 root 2, which means I could just smush it all together and say it's negative root 3 minus 1 over 2 root 2. Okay, so not hugely impressive, but that's one thing we can do with this. And then I'll show you some other problems that involve this in later videos. Okay, thanks for watching.